Okay, great. So we are in some additional notes. I could teach a new concept within regression, but I think that it makes more sense for us just to get some more practice while I'm not in class. This, why don't you go ahead and read this, and we'll circle back after you read it. All right. So assuming that you read it, okay, this analysis examines the relationship between violent crimes and socioeconomic factors across U.S. states in 1980 and 1980, employing from comprehensive crime statistics data spanning from 1980 to 1993. This data is crazy. Our model focuses on how violent crime rates are influenced by unemployment, youth population demographics. The response variable, however, is the number of violent crimes per 1,000 residents. Okay. Um, so this is, you can imagine in terms of working with this data, it's different from what we've seen in the past. I know it's a little old, but since it's so robust, you might as well use it. Okay, two key explanatory variables were selected: the unemployment, okay, UNEM, and the proportion of population age 18 to 24. So we're looking at how unemployment and young people, or at least the number of young people in an area have an impact on violent crimes. Okay, these variables were chosen for their theoretical significance in criminology and their statistical properties. Unemployment serves as an economic indicator of social stress, because if you don't have jobs, you got to make something work, potentially driving crime through economic necessity and social disruption. The adult population proportion captures a demographic significant age group often associated with higher crime rates due to factors such as economic vulnerability and risk-taking behavior, whereas adults don't do that. So the model, that's not true. They don't do it, but it's more seen in this age group than older individuals. This model structure allows for clear interpretation of how changes in unemployment and youth population percentages related to percentage changes in violent crimes, making the results particularly relevant for policy decisions. Additionally, these explanatory variables are expected to have low multicollinearity. Let's see, enhancing the statistical reliability of our findings, while maintaining theoretical soundness in criminology research. So again, we have our summary statistics. Okay, we have the min, the max that we're really interested in terms of making predictions, as well as the mean and standard deviations. Notice that these percentages are in decimal form. Don't get caught on a quiz in the future. Okay, so be aware of that. Okay, that these are in decimal form. Okay, so it's in between 5 and 15%, and then 11 and 15% for unemployment and age. Okay, here's a correlation. They're highly correlated. The explanatory variables are highly correlated with the response, which is nice. We're going to see that in the scatter plot as well. But there is an association between the explanatory variables that could be problematic. We'll see with the VIF score of multicollinearity. Okay, so be aware of that. And now let's look at the scatter plots. So in terms of the positive association between unemployment and crime, we see that as crime increases, unemployment increases, but it seems as if there's a negative association between crime and age. One of the key things to note in terms of this visualization is that this is skewed right, and pretty much symmetric. With this skewed right, in statistics, we can make a transformation with this data. And depending on how the quarter progresses, we might talk about these transformations in class. So be aware of that. Okay? So transformations, we could transform this to make this more symmetric. Okay? So then here's our analysis. Okay? So again, ignoring this element, we don't ignore this. We can write our regression equation. We have the standard deviation of residuals. We have our R squared that we use. Okay, only 5% of variability is explained. It's not a good model. We have our F statistic. Okay, and then we have our p-value. Hence, what we should do, right? And then finally, we have the scores of multicollinearity. There's a reason why they're the same value. If you take stat 324, you'll see why by way of the equation. But yeah, multilinearity is not a problem here. Okay. With that being said, I'm already getting rid of, or at least stating some of the Easter eggs. This p-value being large indicates that based on our data, none of the explanatory variables have a linear relationship with the response. Granted, I know we see here that we would decide to reject our null hypothesis for both of these, but look how close it is. Look how close both of them are to actually 0.1, right? So, I mean, it's never going to be a perfect system, and it is what it is, and that's even highlighted in our low percentage of variability being explained by our regression model. Okay, all right. So with that being said, let's answer some questions. Let's answer some questions. So they're very similar from before, last conceptual questions. List all the variables, right? Response variable already mentioned is going to be the violent crimes. Okay. And then explanatory variable is going to be unemployment and the proportion of proportion of people that are 18 to 24. Okay. In terms of, again, you can pause this, and I won't post these until I'll post them. It's fine. So in terms of range of plausible values for the explanatory variables, you just go to the summary statistics to look at those values. And so I already made the conversion for unemployment is in between 5.44 and 15.5. And then for youth is in between 11.6 and 15. Okay? So they need to stay within those bounds in order for you to make accurate predictions based on the data. So analyze the distribution of the violent crime violent crime rates, unemployment rates, and youth population proportions. What I'm really asking for is just to look down this diagonal and what do you see? So I'll say this is skewed right, semi-skewed right, and pretty symmetric. Okay, and they're all unimodal, right? They're all unimodal because it only has one mode, one hump. Okay, hopefully you see that. Does it say? Non-normality. I'll say this is, I'll say this is skewed right. I'm going to say that. Slightly, but not as much as unemployment. Okay. I'll erase that. Slightly. Okay. But this is a huge concern. Huge concern. There's nothing we can do about this at this moment because we haven't learned about making transformations, but it's important to note, okay? Because it has an impact on our predictions, right? Okay, we'll keep going. So, model prediction. Write out the regression model, okay? We should be able to do that as well as provide an interpretation. I'm actually going to say pause this because the other stuff we should have been able to, know. But pause this and try it yourself because this is relatively new in terms of making interpretations for our regression coefficients. Okay? So ideally, you should have been able to write this out, right? The y-intercept, the regression coefficient for unemployment, the regression coefficient for the age. But then in terms of interpretation, remember, for the y-intercept, we're going to assume both of them are going to be 0, okay? Which is uninterpretable. Okay, well, you could have 0 people that have that age range. It's true. Could you have 0 unemployment? That's true as well. But does it make sense to have a negative crime rate? No, it does not make sense to have a negative crime rate. Okay? On both explanatory variables. And I need to add context. Explanatory variables being unemployment. Unemployment and age between 18 to 24 are 0. Let's do some quickly spell checks. Okay, boom, got it. Okay. So again, this is not meaningful because you can't have a negative. So you need to make sure you provide that when you're providing the interpretation. You can't have negative crime. All right, so then in terms of the 34.103, as unemployment increases by 1 unit, right, the average, okay, as 1 unit increase in unemployment is associated with 34.103 increase in violent crime per 1,000 residents. So this specifies observation unit on average, holding youth population constant. Okay, holding statement is new. Okay, that needs to be mentioned. Whereas 1 unit increase in youth population is associated with 115.133 increase in violent crimes per 1,000 residents on average, okay, holding unemployment constant. Okay, so we should see the parallels between these two, and that's it. Okay, so then here it says calculate the predicted violent crime rate for a state with 6% unemployment and 12 population age between 18 and 24. Okay, make sure, as it says before, further, evaluate whether this prediction makes sense. If you look between the min and max, 12% is in between 0.6, or 12% is in between unemployment rate, and 6% is in between unemployment rate, and 12 is in between youth population. So we're good to go there. And so, but mind you, look what I do. I convert this. I convert both of the percentages into decimals. So you need to pay attention to the words as well as the minimax of the data in the form that's provided. Okay, so once you do that check, now we can plug it in. Now we can plug it into the equation and notice that the average, remember the average, 2.2818 violent crimes per 1,000 residents when youth population is 12% and unemployment is 6%. So it's restating what those explanatory variables were. Okay, so that's huge. So being able to make predictions is huge. Making interpretations is important. And I believe it's time to do the omnibus test. Yes, the omnibus test. So we're testing both of the regression coefficients at the same time to see if there's any utility behind this particular model. The null hypothesis is that both of the explanatory variables are 0, aka indicating explanatory variables regression coefficients are 0, aka indicating that there's no linear relationship between the response variable and the explanatory variables, whereas the alternative is that at least one does have a linear relationship. Okay, here I provide the context as well as the symbols. Okay, and then in terms of the regression coefficients, this technically should not be written because there's a lot of different combinations that are possible. I'll just erase that. That's fine. Our test statistic is 2.46, and then our p-value is 0.101. We're going to fail to reject the null hypothesis, right? Indicating that based on our data, there is chance that these regression coefficients are that these regression coefficients are 0 based on the data. Okay, and granted, I know granted in the analysis that we decided to reject the null hypothesis for those two values, but again, in both decisions, we could be making a mistake, and we're just limited to the data that we have access to. Okay. All right. So unemployment effect analysis, evaluate the significance of unemployment effect on violent crimes. So this is just asking us to do it says state the relevant hypotheses, a simple non-alternative based on just one of the explanatory variables, which is unemployment. So we're going to say that the null hypothesis is that beta 1 is equal to 0, right? Is it beta 1? That the first one represents unemployment? Yes, that's true. Beta 1 is equal to 0 versus beta 1 not equal to 0, indicating a linear relationship, not a linear relationship for the null and a linear relationship for the alternative. Okay. Once you do that, the test statistic is going to be found right next to, I have to do that. Okay, this is the test statistic and the corresponding p-value. And I know we're going to reject the null hypothesis, but we all know that there's plausibility to be making a type 1 error for this particular test and a type 2 here. Okay, we would reject the null hypothesis at a level of 0.1. Okay, there's slight evidence for a linear relationship. And then in question 8, I asked you all to create a 95% confidence interval for beta 2, essentially the young adult population proportion impact on crime rates. Okay, the math is seen as such. You have point estimate plus or minus critical value times standard error. We have these values. Look, based on the data, zeros included. Okay, so it's plausible, right? We're 95% confident that the population parameter regression coefficient, I should say that to be more exact, regression coefficient, okay, representing the effect of the linear effect of youth population proportion on violent crime lies between negative 18.72 and 248, holding an unemployment constant. Okay. It should say holding proportion of age constant. Okay. So, with that being the case, we could be making a mistake. That's important to know. And I would say this is just more so a function of a small data set. Discuss the policy of if zeros are contained within the lower bound and upper bound. What does that suggest about the relationship between these two variables? Okay. The confidence does contain zero. Can't conclude a definitive relationship. Again, insufficient evidence to either reject or fail to reject. It's not strong. Okay. We need more research. I'll say we need more data. Okay, that could potentially have an impact on our analysis. All right, question 10. Model metrics. The first one is going to be the standard deviation of residuals. We specify that, okay, which we can see what it means. Observed violent crime deviates from the predicted rates by plus or minus 3.27. That's a new interpretation which would work as well. Adjusted R-squared is the percentage of variability that's accounted for, the percentage or proportion of variability that's accounted for by the regression model. Again, we're using adjusted R-squared because of adding additional variables. We should penalize the regression model for adding additional variables that don't necessarily explain more variability. And so that's pretty low. It's very low. You go from 0 to 100. This 5% is pretty low. This model is not great. VIF, both of the VIF scores are in between 1 and 4. Okay, so there's not that much. So there's no multicollinearity, pretty much, or none to little. Not that much multicollinearity. Sorry. And then fourth is the omnibus test, and that's us even just testing if there's a relationship. I say 0. Let's say 0.1. We're going to fail to reject the null hypothesis, indicating that this model has no utility. Okay. That's pretty much it for questions. I hope that this provided further insight into multiple linear regression, where the explanatory variables are both quantitative, but we are going to do or learn a situation where our explanatory variables are not quantitative, or not, both of them are not quantitative. So we'll look at that. Thank you for your time. Hopefully you didn't watch me at, so maybe you watched me at 2x, that's fine. But thank you for your time.